let's open up the exam. Do you have the exam open? Good. Well, while mine's loading. We have to finish the last question in section A. What was that?
Give the definition of volt.
Ah. Let's do that. So,
1 mark.
1 mark. Do you remember what it is?
No.
The heck?
Oh.
Stuck. Oh, here we go. Right. Volt. How can we put this? A 1 coulomb charge is said to have 1 volt of potential difference between 2 points if how can I put this? If 1 joule of work can be done by moving the 1 coulomb between the 2 points. I'm sorry, this is not the best sentence at all. In my head, I'm picturing this. You have A, you have B, you have 1 coulomb, and if you move 1 coulomb from A and B, and it can do 1 joule of work, then we say that we have between A and B 1 volt. This is the idea. It's like 1 volt is 1 joule per coulomb. So you could say sort of like 1 volt is 1 joule per coulomb, you know. I don't know what the marking scheme has. I would have to look at it.
Oh, maybe I can.
Do! Check what you have.
Oh, voltage is electric potential energy per unit charge, measured in joules per coulomb.
That might be okay. Shall we check the marking scheme? The MS.
Okay.
See what they say.
MS is
Marking scheme. What did you think it was?
1 joule of per PD per coulomb. Sentence to contain this concept.
Okay, so the only thing they care about is that you mention 1 joule, 1 volt and 1 coulomb in the sentence. Fine. Fine. Okay, let's see.
Yeah, and the B question.
Oh yeah, there's a B part. Let's do that now. Okay.
I know how to do this.
Too easy?
Yes.
Skip it?
Yes.
Are you sure you can do it?
Yeah, I do this
Okay, good. Fine. Fine.
all the time.
Right, now, what I'd like to do, Ben, before we do more, is I want to say what questions I would pick in the exam. So, question 1, what topic is this? You have 6 topics. Mechanics, materials, electricity, waves, fields, and atoms. Which topic is this? So do or don't do? No, you should. It's great. It's a great question.
Actually, I have no idea for this question.
Really? Okay. Then I should do this one now. This one is mechanics. It's mechanics about the pendulum.
Yeah. Maybe I will.
It's okay.
Yeah.
This one is fields. Don't do this one.
Okay.
This one is waves. Waves are okay. It's okay. This one's another atom question. I would do this one. And this exam is very strange because this exam is missing a question about a graph. It's very strange. There's no question that asks you to make a graph. That's strange. Most exams ask you to make a graph. It's strange. You don't like the atoms question?
For this one, I don't.
Right, well, let's have a look at it. Do you remember the electron volt? EV?
I just know it's in terms of joule.
Yeah. What happens here?
Can we just say 1 EV equals
E joules.
1.602 10 minus 19 joule?
I don't think so, because of the verb. They didn't say what, they said define. If they said what is the electron volt, maybe. But because they said define, don't think so. But look, here's the easy way to remember it. Okay, you have two plates. Okay, this plate is negative, this plate is positive, and here is 1 volt. Okay, and here is 1 electron, and this 1 electron will move from here to here. Okay, here it has potential energy, and here it has kinetic energy. We say that the potential energy it has, we call that 1 EV. So, an electron in a field of potential difference 1 volt will have 1 EV of potential energy. That is 1 EV will equal, what do you say, 1.602 times 10 to the minus 19 joules.
Because Gao can give me the V3.
I can give you more exams. Just email me.
It's in the morning. You know.
Oh yeah, you emailed me at like 6 o'clock. I was asleep.
What?
Yeah. You're awake at 6 o'clock. It was too early. Okay? Right. Next. What is the energy required to ionize in the ground state?
I don't know.
Fine. The word ground state just means, it's a word in physics that just means E0, the lowest orbit. That's what it means, okay? So in this picture, oh, well, actually, they start at 1, sorry, not 0. In this picture, E1 is the ground state. So all they want you to do is change minus 13.59. That's E1. If you want to free it, then you must give it 13.59 joules, EV, to free it. They want you to turn this into joules, so just multiply this by E. What do you get?
Why they didn't say that?
I'm sorry, part of the exam is English.
But can I see what's the
Yeah,
question?
yeah.
Determine the energy required in joule to.
You know this word from chemistry. You know this word in chemistry. It means free. Ionize, ionization.
Yes. Ionize electrons in the ground state of hydrogen. What means hydrogen?
What means hydrogen? They're saying that this picture is for hydrogen. Hydrogen atom. H. This is, you learn orbits in chemistry, right?
Yes.
What's the first orbit for hydrogen, H? Do you know it?
First of.
Yeah. You know, like S and P and
S.
yeah. S1, what is it?
1S.
1s, okay? What they're saying is the energy level in 1s is this. The next orbit, do you know the next orbit for hydrogen?
2S.
2s. That's its energy in 2s. Then the next orbit, it's and so on and so on.
Okay.
See, it's not so bad. It's not so bad. That's not bad.
It's
not. It's great, actually. Yeah? What you get?
2.18 times minus 18. 18.
Yep, yep. An electron transitions between which two of the numbered levels shown in the diagram and in which direction will produce the photon with the highest frequency? So, if the electron is here and it falls to here, it loses energy.
Yes.
But this energy isn't lost, it was just changed. So like, for example, if it goes from 0 to minus 1.51, then that means it must have made a photon with energy minus plus 1.51. So I'll draw the picture here. Here's the electron. Its energy right now, for example, is 0 joules. It falls down. Its energy is minus 1.51 eV. This is wrong because the total still needs to be 0. So we have minus 5.51 eV plus some other energy must equal 0. This other energy is the photon that comes out. The question is, what movement will make the highest frequency? Now, because E equals HF, the highest frequency means the highest energy. The highest energy here means the most negative here. So, to me, if the electron goes from this to this, it will make the photon with the highest energy and highest frequency. So for the answer is from n infinity, which means that it's free, to n equals 1, which we call the ground. That's the answer.
What's n?
N, the orbit number.
Oh.
Orbit 1, orbit 2, orbit 3.
So what's the question? Why you says will produce a photon with a high frequency. So, in which direction? Okay. So I can if I don't know, I just guess. I know.
Highest to lowest, yeah.
So it's from. Okay. Yes.
Okay, next. Right, from 2 to 3. Okay, so Ben, what's the difference here between these two? That is 1.89? There you go.
Yeah, 1.89.
Okay, so you have 1.89 equals HF equals HC over lambda. They want the lambda. That's HC over 1.89 E. Yeah, great. Easy peasy.
6.62.
For what?
H.
I can tell you right now, if you look in the exam, here it is here at the start. There it is. Can you see?
It's 3. It's okay. I want to use 2. What is the
E?
No.
Oh, the C?
No.
What?
Not the C. Is
What?
energy
1.89.
So should we use EV or Joule?
Oh, you should use joules. That's why I put the E.
I get 6.56 10 minus 7.
Yeah? So, you know how I like it. 6, 5, 6 nanometers. This makes me happy. Okay, next. Right. Oh, sorry, you need to write it down. Yeah? Low pressure hydrogen gas emits light. The light is analysed using diffraction grating with line space and that. Okay, so D is 1.5 times 10 to the minus 6. Okay. The second order maximum of one spectral line is observed at 9.36 degrees. What is the frequency? Okay, so you know the formula, n lambda equals d sine theta, yes?
This is from the wave, the
Yeah.
double slit.
Double slit, yeah.
But this is what? Oh
Now wait, we don't want lambda, we want f. So nc over f equals d sine theta, right?
yes.
So f equals nc over d sine theta, which equals 2 times 3 times 10 to the 8 over 1.5 times 10 to the minus 6 times sine 9.36.
Sine 2.46 times 50. In this part, they want F.
Yeah.
And
Sure. I'm not going anywhere.
we need n lambda equals d sine.
Yeah. Which transition is responsible for the emission of photons producing this spectral line? Now that's interesting. So what's happening here, Ben, is the electrons are moving between levels, and this is making the light. And they want to know, for this frequency, which transition was it? Which movement was it? So what we need to do is convert this into energy. So energy equals HF for the light. But these energies are in EV. So we should make it into EV by divided by E. So if we take this in here, let's say 6.63 times 10 to the minus 34, wasn't it?
Yes.
Times 2.46 times 10 to the 15 over 1.602 times 10 to the minus 19.
Ten
10.2 EV. Okay. 10.2 is probably
1 and
1 and 2. Is it exactly 10.2? But this is, oh yeah, you round it off. From n equals 2 to n equals 1.
Oh. Isn't a 1 to 2?
No, because you want to, well, let me just double check actually. Yeah, it's emission, meaning releases the photon.
Oh.
Yeah.
Yeah, I know what you mean.
Yeah, good man. Okay. Ah.
But if they,
The English, I know. it's
the
hard.
person, if they just say the direction straightly, not just. If they just say, what's the energy, what's the F frequency?
But then it's too easy.
Why?
It's just a simple calculation then. It's too easy.
Yeah. And
Okay. Light from the discharge lamp in B is instant upon a metal surface. The metal has a work function of. Okay, so the work function is 5 times 10 to the minus 19 joules. Explain. Okay, so here you have the metal, and here the light comes in, the photon comes in, and out should come an electron.
Yes.
Explain why photons produced by the transition of electrons from 3 to 1 can cause the emission of electrons from the metal, but photons emitted due to the transition between 3 and 2 cannot. So what they're saying is, if this photon was made because it went from state 2 to 1, it can release an electron. Whereas if it went from 3 to 2, it cannot. So the reason is probably because this one has enough energy, this one is more than the work function, and this one is probably less than the work function. Now I think we should change these into EV, make it easier. So what's this in EV, please?
So just over. Sorry, I think I just 5 over 130. So it's 3.12
EV. So from 2 to 1 equals, and from 3 to 2 equals, so let me see, go back to the picture. 2 to 1, oh that's
like
10.2, wasn't it? Roughly 10.2. So you can see 10.2 EV, that's more than 3.1 EV. So then that means it's freed. And then 3 to 2, oh, much less. 1.89
like
1.89 we had earlier.
Yes.
Which means it is not freed. That's it.
That's easy.
Yeah.
But you know, last night, I see the question. What? Like I see.
It
what?
looks hard, but it's easy.
I have no idea what this for. But you say you explain. I think this easy question.
It is an easy question.
So if I just write down this, you can. Or
I think this should be okay. Let me see. What exactly did they say?
I need to check this. Either convert.
Yeah, either convert work function to EV, which we did, and then compare. Yeah.
Transition EV to joules.
Yeah. Yeah, this is good. This is what we did.
So we did.
Yeah, just full marks. Yeah.
Oh. Why they at D? Is none? Free.
Freed, yeah. Like adjective. Like okay, I'll explain. Free the electron. The electron has been freed. You know? Like, drink the coffee. The coffee has been drunk. Or is it drank?
Like the part.
Is it drunk
PP.
or drank?
PP.
PP? Past participle? Yes. Past participle.
So
Yeah.
actually like none.
Like what?
None.
I'm not sure what you're saying, but yes, this is, I'm using PP here.
Okay. So yes. Let's do the next question.
Well, the last one for this one is what is the threshold frequency?
Oh,
The minimum frequency. So do you remember you have the formula, what is it, HF
yes.
equals KE, what's it, KE plus work function, isn't it? No, what's it? Work function equals KE plus HF, isn't it?
Yes. Maybe I can check.
No, I'll check. Let me just think. It starts off HF minus work function equals KE. Yeah, HF equals work function plus KE. The threshold frequency is when the KE is 0. It's the minimum frequency.
Yeah. So, I remember this part. So, F0 equals something over H. What is
Work function.
work function? Is 7.54 times 40. So
Threshold,
threshold.
not treasure. Treasure is different to threshold.
Yeah, I know.
Good.
Work function equals energy HF. So it's threshold. So what's the one? So frequency.
Okay. Now, what I want to do with you, Ben, is I want to do the other atoms question.
Okay.
Because I want you to love atoms questions. But I don't think you do.
If I do I will do this. I think it's okay, but before I do this, I will sure I can understand the questioning.
Yes, I think so. We'll practice more. So, this is B5. What they've done here is a little different this year. They've given you 4 statements, and you say which are true or false for fusion. Now, which one is fusion? Is fusion this one or this one? Is it you smash the isotopes together, or
Smash this one.
yeah, you put them together?
Yes.
Yeah, okay. So, first one. The total binding energy increases. Now, to be honest, I don't know. I have to think about that. Let's think about it.
Bonding energy, I think.
Oh, I know binding energy.
What's bonding energy?
The energy that keeps it together.
The bonding energy of electron is the energy required to hold the nuclear together. The energy, okay.
No, actually, I'm not sure. I have to really think about this one. So, if you remember if you look here, you remember your graph of binding energy goes like this. And we said, on the left is fusion, and on the right is fission. And usually what happens is you have two small nuclei, and you put them together to make a bigger one. So maybe you have like a hydrogen and another hydrogen, and they come together and they make helium. Now, my only problem is when they say total, do they mean everything total, or do they mean just for one nuclei? You know, like here, this is hydrogen plus a hydrogen, that makes a helium plus energy. Okay, this one has a binding energy, I'll call it B2. This one has a B1. Now, I know B1 will be smaller than B2. No problem. What I don't know is this B1 plus this B1, is it more or less than B2? Let's think about this. We get this energy because the mass is less.
Yes.
Japers, Ben, I don't know.
You mean but I remember you say the energy change to make they together.
I'm going to take a guess. I'm going to say it's true.
Oh, you mean what's the question?
Does the total binding energy, now they don't mean this energy. They're not talking about this energy. They're talking about the binding energy to hold it together. Does that get bigger or smaller? I'm going to say bigger. I'm going to say it's true. And I'll be sad if I'm wrong. A is true. Okay, good. Right. Now, B, nuclei join together. Oh, well, that's true. So, A is true. B is true. Okay. Oh, well, this one's good. This one has to be false if we said A is true. Binding energy per nucleon decreases. No, we said it increases, so C is false.
What's mean?
Yeah.
What's the total bending energy increase in this process? You mean which total? Like you say B1.
B1 plus B1, I think, is smaller than B2.
So decrease.
No, increase. I said B1 plus B1 is smaller than B2.
Oh.
Yeah? Oh no, it's total, not per. Yes, actually, sorry Ben, the first one was total, not per nucleon. So actually what I should have done here, this has 1 and this has 2. So it was one of these, and then 2 of these. Yeah, anyways, it doesn't matter. It's fine. Energy is released in this process, true or false? What do you think?
Yes.
Yeah, oh, true. Yeah, okay.
And
Right.
will really
Yeah, easy, true. Okay. Now, what about for fission?
No, I don't think so.
Fission?
No.
Well, let's start. A. I think it's going to be the opposite. It's false. Nuclei join together for fission?
What's
False.
together?
They come together.
No, false.
False, yeah. Binding energy per nucleon decreases. Well, here it was false, so here I think it's true. But the last one, energy is released in this process.
Yes.
Of course. This is the only one that's the same. And all of these, I think, will be opposite. Let's check. ABD, AD. ABD.
Oh.
AD.
So A and 3 is opposite.
Oh my goodness.
They're wrong. They're wrong.
Binding energy per nucleon decreases. They said this is false. Should have been false. And they said A is true. That's terrible. That's terrible.
So we can remember the total energy always increase.
The total binding energy always increases.
Actually, I'm not sure what's that.
I think I understand why, Ben. Let me explain. I have an idea. You said it always increases. I think I can explain why. So you have fusion and you have fission.
We learned about fission more.
Yes, because it's more common. Yeah. So with fusion, you take 2, they come together, and they make 1. And also plus energy. This extra energy comes from the mass change. This has a binding energy, this has a binding energy, and this has a binding energy. But these also have kinetic energies. So I think what's happening is B1 plus B2 plus KE equals B3. So that must mean B1 plus B2 less than B3. That's what I think. Here with the fission, you have 1 here, but remember what you do is you take a small guy and you fire that in to break it. So this has a KE, this has a B1, this has a B2, and this has a B3. And again, I think KE plus B1 should equal, no, it's the opposite, is what I thought, B2 plus B3. So if you remove this, you say B1 is, but this becomes after. After is bigger than before. This is the same, after is bigger than before. So yeah, it looks like the B increases, and I think the extra, because the energy must come from somewhere, I think the extra energy comes from the KE, because the KE is gone. That's what I think. Okay, that's good. That's good. Okay, so.
But they have two, I think they have two ways to ask, like total and per.
Yeah, per. So for per, you need to look at this graph. So this one here is fission. So what happens is you always move down it, don't you?
Yes.
No, the other way. You start with something big like uranium,
Oh yes.
and you move this way. So that means this is energy per. Looks like it will increase. So if I look back at what one, binding energy per nucleon decreases. That is false for fission. So that should be false. Okay, no, I'm happy now. This makes sense, yeah. Okay. I think the most difficult one is the first one. But I don't want to forget something here. Yeah, we'll continue, don't worry. Yeah, absolutely. Because Einstein's equation, I should say, the binding energy comes from kinetic energy. The binding energy of an isotope is the energy required to hold the nucleus together. The energy is equal to mc squared, where m is the mass defect. That is the apparent loss in mass when the proton and neutrons are combined together. This is energy also required to separate the nucleus. That is, it is the kinetic energy needed to break the nuclei apart. There now. This is for next year. Okay. Continue. I know, so that one was a little bit difficult, but let's see. Give the function and suggest a property of the following. Okay, so firstly the function and then a property. So what does the control rod do? What's its function? What's its job?
Yes, so reduce the real
It should reduce the fission reaction. Yeah, good, okay. And the fuel rod? What's the job of the fuel rod?
Provide
Yeah, go on. Go on, yes, good. Provide, yes.
provide integration.
Provide the what?
Integrate.
What word? Integrate. No. Try a different word. Simpler word.
Energy.
Yeah, so firstly, what's the fuel rod made of? It's usually made of uranium, okay? So the function of the fuel rod is to provide energy, radioactive energy. It's usually made of uranium or plutonium, yeah. And lastly, the moderator. What's the job?
Also, like reduce the.
Yeah, reduce it. But what's the difference between this one and this one? That's important. They both reduce it. But the control rod could also increase it because you can change it.
Yes.
So we need a word. Here the verb is reduce. But what verb should we use here instead to mean?
Both.
Oh, okay, yeah. But okay, fine. Both is fine. But could you give one word? So you could say increase and decrease. But we got one word for both. That's okay. You can say increase and decrease. But what I was thinking of,
Up and down.
adjust or alter.
What?
You don't know this verb?
I don't know.
Oh, adjust. It means to change. Up or down. Yeah. Okay, fine. Right, now. Next, we want a property.
Well, probably.
So let's see what. Okay. Something good or bad. A property. So, what's the control rod usually made of? What do we say it's usually made of? Carbon? I forget. Anyways, what do we need the control rod to have as a property? It needs to be good at absorbing neutrons. Thank you. So that's one property. Okay. The fuel rod. What's a property we need of the fuel rod? Yeah.
We need to mix something.
Yes, we do need to mix it. But what do we need? Property we need. Why do we use the fuel rod? Because it gives energy. So a property is it must be radioactive. Must be. Yeah? And what about the moderator? A property. What do you think? Any ideas? Well, it's kind of the same as the control rod, isn't it? But the problem is, in the marking scheme, they say, do not allow repeat. Okay, so you can't use the same reason twice. So we need to think of something that's a little bit different between this and this. One difference I can think of is the control rod is usually a very good solid absorber, whereas the moderator is usually not as good liquid. Yeah. So we could say that this is a very good solid absorber of neutrons, a poor liquid absorber of neutrons, highly radioactive. There's the three properties. Okay, this is 6 marks, you know. It's okay. Shall we write something down or what? So for the first one, it just. Okay, so hang on. Let me just. Jeepers. Function. Property. 1. adjust either up or down, as you said, the rate of fission slash neutron rate. Neutron rate. 2. Release radiation energy. Number 3, to reduce neutron speed. Okay. Property number 1, we said a good solid absorber of neutrons. Number 2, highly radioactive. Number 3, a poor liquid absorber of neutrons. No, okay, how can I'll put it here. A property is like a fact or a feature, or usually something good. Let's think of an example.
You just describe something in this part.
Yeah, I'm trying to think of an example. Doesn't have to be something good, Doug. You could say a property of Dublin is that it rains a lot. You know, it doesn't have to be something good. Where's Gao? Is it? Here's Gao. I was wondering if that was you. You're very, very, very late.
Yes, I
1 hour and 10 minutes late.
I thought I was started 10, and I saw his message late. He told me around 9.
What music are you listening to? Korean pop? K-pop?
No way.
Oh, English, okay. Right, continue. Okay. In a nuclear fusion process, 4 hydrogen produce a helium. Hydrogen is that, and helium is that. What is the change in mass?
That's Kelvin.
Oh, so it's just this minus this.
Yes.
Now, just be careful, Ben. It's this minus 4 of these.
Yeah.
Yeah, okay.
It's minus.
Can I see? Oh yeah, we don't want to use minus because they want the change, so they don't care about the minus. Yeah, so it loses this much mass, but they need this in kilograms. So, Ben, if you can take this answer and multiply it by U, which is here. That's U. What do you mean what?
we get this mass is
They want it in kilograms. This is the answer. Write that down. What? What's wrong?
so what we calculate
Determine the change in mass. Oh, they don't actually say kilograms. But because it's 3 marks, I feel like it should be kilograms. Because it's 3 marks, not 1 mark.
oh yeah they say kilogram in kilogram.
Do they? Oh yeah, there it is. Yeah, nearly missed that.
So so we just calculate one atom.
Yeah, so what they have is four of these come together. 4 hydrogens make 1 helium. But it's actually helium-42. And this is 4 times 1,1H.
What's the unit?
For kg, we said.
This kg.
Yeah, what answer did we write down?
4.676 10 minus 29.
Kilograms. Okay, next. What's the energy? Well, what form? Yeah, E equals mc squared. And we have the m. So, easy peasy. Multiply it by c squared.
So we use the kg.
Yeah, you must use kg. Look, we already have 5 marks. How many do you need if you want 100 kilojoules? So you just take 100,000 and divide it by this number. That's how many of this process you'll need. And that is 2.33 times 10 to the 16.
Can I see what's the question?
Yeah, sure.
Oh, 100, okay.
Next, how many moles? So, how do we change this into moles? Come on, you know this from chemistry.
6 point
Divide by 6.02 times 10 power
23.
23. So this is 3.87 or 88 times 10 to the minus 8 moles. How many marks for that? That is 2 marks. Assuming it's 100% efficient, how much mass per hour do you need if you want 100 kilowatts? Okay, so let's just think about this. In 1 hour, we want to have 100 joules, because 100 kilojoules, because this means 100 kilowatts. Okay, we know that this means we'll need 3.88 times 10 to the minus 8 moles per hour, because that's why they had you calculate this. But they want this as mass. So what we have to do now is multiply this by the molar mass. What's the molar mass? Or no, actually you don't even have to do that. What you could do is, if you want it a little bit easier, you could take this number and multiply it by hydrogen. There's hydrogen. There. So it would be 2.33 times 10 to the 16. This is how many you need per hour. And remember, each process uses 4 hydrogen. So we'll take this number and multiply it by 4 and then multiply it by 1.00782 U. That's what you'll need per hour. I don't. What's U? 1.66 times 10 to the 23. Is it? Minus 23. Is it? Let's see. Where's U? Yeah, 27. So you would need 1.55 times 10 to the minus 10 kilograms. That's 1.55 times 10 to the minus 7 grams. That's 155 micrograms. Per hour. That's just the hydrogen. Let's check the answer. Ooh. 5.62? Ah.
No.
That's what I did. 4 times that answers the part 3. 2.33 times 10 to the 16. Yeah. Did they miscalculate?
No.
Oh, they multiply by...
Oh, the S second. They don't use hour, they use second. So this.
I'm just confused why they have the 60 and the 60. Ah, this is my mistake. Earlier, I said 100 kilowatts means 100 kilojoules in 1 hour. This is wrong. 100 kilowatts means 100 kilojoules in 1 second. Because I forgot watts I was thinking was per hour. It's not, it's per second. So this answer I got here is not per hour, but it's per second. So if I wanted per hour, I just multiply by 3600. Yeah, okay, so that will give me 55800 micrograms per hour. This is too big. If I take out 3, that micro becomes, what's before micro? Milli. 558 milligrams per hour. Yeah, okay, 56.62. Yeah, mine is a little bit different, 562, 558. The reason it's a little bit different is I think because of this answer. No, it's the same. Oh well, I don't know why it's a little different. Doesn't matter. Okay, so Gail, you didn't really see anything so far because you were just getting the end of this question.
Mm-hmm.
What we did was we wanted to spend this morning looking at the atoms question because I do like the atoms question in the exam.
Okay.
So I was recommending that if you were doing this exam, I would do question 1, atoms, question 5, atoms, and then you have a choice, waves, don't do the fields, or mechanics. Now this mechanics one actually is nice, it's not so difficult. So maybe I would do atoms, mechanics, atoms. Like for example here, what do we mean by amplitude? We had this word Yesterday, I think.
A,
Yeah, but you have to put a sentence. Give a sentence.
the what's
Displacement? Maybe you mean displacement?
the differences between two?
Yes, you could say it's half the difference between the maximum and minimum displacement.
Oh yeah.
But more simple answer is amplitude is the maximum displacement.
Okay.
Yeah. The magnitude, so the acceleration is this number here, and they want the angular frequency, that's the F. Now let's just write down what we have. I know A, it's 0.45. I know small a, it's 0.711. And I want the angular frequency, that's the omega. So what formula could I use here? I could use the formula A equals minus omega squared x. And the maximum A, which is actually, sorry, what this is, they said it's the maximum, is equal to minus omega squared A, amplitude. So they give us this and they give us this. I don't really care about the minus. No, we don't need to do this because I just want to make sure you know what to do.
I know.
Do you understand now? Yeah, what are you doing? Is this one okay? Let's look at the next one. How do we get the time for the pendulum?
Root
Yeah, 2 pi root.
G over L. L over G.
Yeah, G over L. Isn't it? Now you've confused me. Or is it L over G? You're after confusing me. 2 pi. No. It's L over G. You just confused me. Now the only problem is, do we know the L though? Do we know the L? No. So we can't use that formula. Is there another formula? Yes, there is. T equals. Oh my goodness. T equals something over something. I'll give you a hint. Okay, hint. What did they ask you to calculate here? Omega. So, Ben?
Oh
yes. Yes, indeed. Describe the change in energy. Now, for this question here, they want you to make the graph. Do you remember the graph? The one that looks like this? Here you have X and here you have energy. And here you have A and here you have minus A.
Like this?
Yeah, and one goes like this and one goes like this. Which is kinetic? Is this one kinetic or potential? So the energy is big at A and then gets smaller. It's kinetic or potential? And this one? Now I have bad news. They say describe qualitatively. So what does that mean? Describe qualitatively. Do you know qualitatively? This word in English? No? Yeah? Do you know it? No, okay, so I'll tell you. In English, when they say describe qualitatively, it means describe in words. So I'm sorry for this question. You should draw the graph, but they don't want the graph. They want you to describe this graph in words. So you need to say, blah, blah, blah. The potential energy is a maximum at A, decreases to 0 at the origin, and increases to the maximum again at minus A. It is a quadratic shape. The kinetic energy graph is also quadratic. It starts at 0 at -a, increases to a maximum at the origin, and decreases back to 0 again. Blah, 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 blah. I know, it's a lot to write, but you get 3 marks. Yeah? So here they want the velocity. What formula gives you the velocity? If they give you the time. So, do you remember this one? X equals A cos omega t, and V equals minus A omega sine omega t. Do we know the A? Yes. Do we know this A? Yeah. Do we know this omega? Do we know this omega? Do we know the t? Can we get the V? Yeah. 3 marks. Ooh.
Oh.
Ooh. No. You remember that there's 2 formulas. This one is if it starts on the outside, and then the other one here is if it starts on the inside. If it's the other one, the formula is like this. Now I realized just now we have to use this one here because they say after it passes through the equilibrium. This is a way to say that it starts here in the middle. Okay. Right, sketch a graph. Ah, perfect. So now, in this question, they want the graph for this question. So what you could do is you could go back to this question and just change this to 2v1. And then what you wrote here is just going to be 2iv. So now you get bonus 3 marks. Because you already drew the graph earlier, to help you explain this, you can just change this answer to 2 part 6 and keep what you wrote here as 2 part 4. Because they only wanted the words for the answer. So that's nice. Next. An experiment is carried out to determine the effects of damping. Do you remember damping? Yeah, good. The pendulum is initially undamped. Describe the behavior of the system as the driving frequency is increased through the range. Okay, we did this graph. I don't know if you remember it. Maybe I need to show it to you to help you remember. Do you remember? Here. Gal, what are you doing? Be good.
I'm blaming Summer.
Don't talk to Summer. He's not here. He makes me sad. Right, so here they're talking about the damping, the undampening, and the driven by the mechanical oscillator. I shall show you the picture here once it opens. Come on, open up. Here we go. Where the heck is it? Goodness sake. Come on. Open with image. There, now. So, what they're saying is, Ben, you looking? You have this mass here, and at the beginning, it's just going left, right, whatever. And then you have this mechanical oscillator, and then this also moves left and right, left and right. And they want to know what is the relationship here. And I have the graph. We also did this. They said, as the frequency of this one matches the frequency of this one, the amplitude here gets bigger. So the graph looks like this. So the first question is, describe the behavior. So you can describe it but maybe it's easier just to draw the graph. You can draw the graph and then say, when the frequency of the big arm is equal to the frequency of the small arm, then the amplitude of the small arm is maximum. Do you remember we did this one? It's a long time ago. Yeah? So when this frequency equals this frequency, then this amplitude is maximum. Okay, fine. And then lastly, what happens if you have damping? Whew. Okay, so you remember that damping looks like this. So the question is, the system is now damped by adding air resistance. Describe the effect on the oscillations of damping. So again, they just want this the other picture. Whoops. To describe it in words. So you can draw the picture and then describe it in words. So the description is, as the time passes, the amplitude will decrease until it reaches 0, until it stops. So both these questions here is just asking you to describe those two graphs I gave you in the lesson. So I don't know. Is there more to do? Probably. Oh no, that's the end. So you see part A, mostly calculation. Part B, a little description. What's wrong, Ben? Too hard? You don't like this one? What would you do in this exam? Maybe you would do the waves? Perhaps? You know this one, air, water, and then the two formulas here. Anyways, Gal, I recorded this lesson. Have you been watching any of the lessons that you missed?
Have you watched? I have.
You have watched?
I have a
Or you will watch?
Have you watched?
Will watch. So what have you been doing at home?
Chemistry.
Oh my goodness, you don't care about physics or maths.
No, maths is okay, so we have 2 days.
Is it? You missed, we did a wonderful question yesterday, Ben will tell you.
Okay, but I will do them again.
It's a wonderful question.
Okay.
This one here. Oh, so difficult. Wonderful. Wasn't it great? It was a wonderful question.
Really?
It looks easy, doesn't it? It's wonderfully hard.
Okay. I will do the exam again, and I can watch the video if I can.
Yeah, so just so you know, the plan is, I think, next week you have no classes, but you have physics on Friday. So, if you want, I think Connor will give me B401 Thursday. What time did we say, Ben? 2 o'clock?
Yeah.
2 p.m. to 4 p.m. If you want, you can come to this class for physics.
Tutorial?
Yeah, for questions, if you have questions.
That's great.
Yeah, well, that's if you come and if you have questions.
Yeah, okay.
I don't know, will you come and will you have questions?
Yes.
Because to have questions means you must do physics at home.
Of course.
Of course, yes, but will you do physics at home?
Yes.
You will?
As my second year didn't come to university. Yeah.
Okay, fine. What happened in your first year?
I was too lazy for studying.
Really?
I usually had no.
Really?
So
I'm
not,
surprised.
yeah, it's last year I only studied English for IELTS.
Ah, fine, okay. That's why your English is so good.
Yeah, but I'm not really studying IELTS. That's why I came here.
Thank you for being honest. Alright, what have you got now? Chemistry? Yeah. are you finished chemistry? Just doing revision?
Yes.
And how's that going?
Just okay. Because chemistry definition is a lot, is much than the physics one.
Much worse than physics, yeah?
They already give us the question, each part, like separate each question.
Yes. The physics exam is already separated, you know, there'll be like one, well I don't know how it is on chemistry, but in physics, you know, you have one question mechanics, one question
Yeah, that's
opposite.
great.
In chemistry, is it mixed in one question?
In the B2.
It's mixed?
In section B.
Yeah, but like, so
Yeah,
question
the
one
mixed.
could be about titration and something different.
Yeah.
Alright.
So it's difficult to choose. Like.
It's, yes, it's difficult
Yes.
to pick the best questions, yeah.
Mm,
This is kind of like in maths, it's sometimes mixed, like, but it's usually not so mixed. Like it's algebra, it's calculus, trigonometry, you know. And maths is simple anyway. Ben is very excited about his maths because it's so simple.
We have 2 days before the math.
Yes, it's exciting. It's great.
I can have.
I hope.
Yes.
Yeah, I already booked the movie after the physics.
Don't be too confident.
Okay.
Okay.
I just booked on 19th, so I will review like 20 and 21.
There's an expression in English. I don't know if you know this one. Pride before the fall. Do you know this expression?
Yeah.
You do know it? Ben, do you know this? You do? Really? Very good.
We have similar slang in Chinese.
Really? It means the same thing? If you're too confident, when you are too confident, this is before you fail.
Yes.
Yes. Yes. You have the same thing in Chinese?
Yeah.
Okay, so don't do this.
I have a small plan on my before my desk.
Yeah.
I will follow them, and after finish, I just cross like this.
Oh, so you do have a plan?
Yeah.
Oh, good.
Yeah.
Good, good. That makes me feel better. Yeah. I don't know if Summer has a plan.
I was worried about him as well.
I'm worried about him.
I think he gave up for DCU.
Did he?
He applied again for DIT.
He's trying DIT.
So,
What grades will he need?
C? I think he's same as me, but he didn't come to school as me, much than me.
Yeah, but lately you haven't been coming to school so much.
Yeah.
Like this week.
But I did the revision at home.
For chemistry.
Physics as well, except print all the past papers.
Alright, okay.
To do.
Anyways, if you want, we can have a revision before the exam next week, okay? Right, off to chemistry you go. Oh, my advice is, I gave Ben 8 exams. I think this is a good number.
8?
Like, well, it depends what grade you need. What grade do you need in physics?
C.
Okay, so if you want a C, you should do 4 exams.
Okay.
If you want a B or higher, you need to do 8 exams. Now, look, you don't have to do the whole exam. You know,
just
like,
read the-
yeah, like if you can read and go, oh, I know how to do this, I can do this.
Yeah.
If you want an A, you should have a look at 12 exams. Just make sure you can do all the definitions and everything, you know?
So you think if I want a C definition, it's not so important?
No, because the problem is some exams have lots of definitions and some exams don't have many definitions.
Yeah.
My feeling is that this exam will have some definitions. Now, I think the person who's writing the exam will ask you not too many definitions, but they might ask you a lot of explain, describe. Because earlier with Ben, we were doing the atoms question, and they said, explain the control rod, explain the moderator, explain the fuel rod. I think this is the style of the person. They like this kind of explain, describe. So look, it just means you need to remember your verbs. You know, like Ben, do you remember the verb that means increase or decrease? Adjust. Adjust. You know, like you just need to practice learning some of these verbs. Yeah. All right. Let's close this and let's get the heck out of here. Summer, if you're watching this, good luck.